Today we're covering section 8.5. We are adding and subtracting rational expressions. So a lot of what we've learned in 8.4 is still going to apply here. We're still going to need to simplify. We're still going to need to factor. But now we're adding and subtracting. And so everything we're doing here is essentially just adding and subtracting fractions. So for example, they have this example written down here, the 1/8 plus 1/10. I would like to take a look at that, but I'm going to rewrite it over here on the side so I can make it a little bit bigger. So 1/8 plus 1/10. So if we're adding fractions, as you guys should know, that we then need a common denominator. Now again, dealing with numbers, you might be able to look at this right away and say, okay, we can use 80, or we can use 40, or you might be able to see the common denominator right away. But when we're dealing with polynomials, it's not going to be as easy to see the common denominator right away. So I want to show you a strategy that we're going to use with polynomials that you can also use when you're dealing with simple numbers. So the first thing you're going to do is you're going to factor our denominators. I want to factor 8 as far as I can. So I've got 1 over 8 is 4 times 2, but 4 is 2 times 2, so therefore 8 is 2 times 2 times 2. That gives me 8. And then 10 is 5 times 2. Now, for my common denominator, I want my denominator to have the same factors. Okay, so looking at what I have the same already is I've got a 2 here and a 2 there. So therefore, my denominator needs to have that 2. But then what else is there? Well, this one has 2 more 2's. This one doesn't. This one over here doesn't have those extra 2 2's. So what we're going to need to do is our first fraction already has the 2 2's, but the second fraction doesn't. So we need to multiply the top and bottom of that fraction with 2 2's. Okay, now please remember that multiplying by this right here, that's just 4 over 4. And 4 over 4 is just 1. You can multiply anything you want by 1 and you're not changing it. We're simply changing what it looks like. So, I have this currently. I still need to worry about the 5 because I dealt with all 3 of these 2's, and now I have 3 2's here and 3 2's there, but I still need that 5. So the second fraction already has the 5, okay, but the first fraction doesn't. So I've got to multiply top and bottom here by 5. And again, I am multiplying by 1 essentially, because 5 divided by 5 is 1. So on the top here I have the 1 times 5. On the second fraction I have 1 times 4. So simplifying what I have now, I have 5 over 8 times 5 is 40, plus 1 times 4 is 4, and then again I have 10 times 4, which is again 40. So adding these together we get 9/40. And that would be our simplified fraction. So it looks more complex when we're dealing with numbers because obviously we know some shorter ways of doing this when we have numbers involved. But this is the process we're going to be using with polynomials, and when we have polynomials it doesn't look so complex. So let's give it a shot with our first polynomial example. So our first example, it says, what is the sum of the two rational expressions in simplest form? State the restrictions on the variable. This is something that we're going to deal with later. So for right now, we just don't worry about it. Okay, we don't worry about that yet. We'll worry about that in the next section. So we want to add our two fractions. Well, before we can add, we've got to go through and factor everything we can. So right now we have x over x minus 1, because we can't do anything with that fraction, plus 2x minus 1 over, well, now we have that trinomial. And again, we know that if a trinomial factors, it's going to factor into two binomials. We need two numbers that multiply to give us 2, but add to give you negative 3. So that will be x minus 1 and x minus 2. Okay, so we have these factored now. Notice that our two fractions both have an x minus 1, which is good, but the second fraction has an x minus 2 as well. So our first fraction needs to have an x minus 2. So what I'm going to do is I'm going to multiply the top and bottom of that fraction by x minus 2. Now I have a common denominator. So I can go through and add across the top. So I have x times x minus 2 plus 2x minus 1. And that's going to be over x minus 1 times x minus 2. When we add fractions with a common denominator, we just keep that common denominator. Okay? Well, we need to simplify the top. And in order to do that, we have to distribute the x. So we have x squared minus 2x plus 2x minus 1. Okay, because the key here is they want this in simplest form. You always want to reduce your fractions. So looking at this, looks like we have, when we combine negative 2x plus 2x, it goes away. So that gives us x squared minus 1 over x minus 1 times x minus 2. Okay, well, we're very close to being done, actually, except this guy is a difference of perfect squares. So that can be factored. We're going to factor that into x plus 1 times x minus 1. And then sure enough, the x minus 1's cancel out. So our simplified answer is x plus 1 over x minus 2. Let's see what happens in this next one. So again, looking at our denominators, we need to have a common denominator. And looks like this second denominator can be factored. We can pull an x out, which leaves us with x minus 1. Okay, so our two denominators have the x minus 1 in common, but the second denominator also has that x. So therefore, we need to multiply the top and bottom of this first fraction by x to give us that common denominator. So we have x times x plus 1 over x times x minus 1 plus negative 2 over x times x minus 1. We now have a common denominator, so therefore we can add across the top. Now again, adding fractions, you just add straight across the top. Leave the common denominator alone. So we have x times x plus 1 plus a negative 2, or minus 2, over x times x minus 1. Well, we want to simplify this fraction. So in order to see if we can simplify it, we first have to work with the top. We're going to have to multiply the x through. So we have x squared plus x minus 2 over x times x minus 1. And now we've got to see if we can factor that trinomial. So let's see here. We're going to have an x and an x, and now we want two numbers that multiply to give us -2, but add together to give us a +1. So multiply to give us -2, add to give us a +1. It must be +2 and -1. Well, now that we have it factored, we can see that we can actually reduce this fraction by getting rid of the x minus 1's. So our final answer is then x plus 2 over x. Please remember that you cannot cancel these x's. You cannot cancel those because this top x is not a factor. It is a term. It's attached by addition, not by multiplication. So our final answer is x plus 2 over x. Okay, on the back side of your notes, we are now subtracting fractions, subtracting rational expressions. So to do this, it's the exact same process as adding, except there's going to be one little thing towards the end that we have to take care of. But let's first go through and see if we can factor. And it looks like we can. Our first denominator can be factored into x times x minus 2. And the second denominator can be factored into 2 times x minus 2. Well, notice they have an x minus 2 in common, but the first fraction has an x, the second fraction has a 2. So that means we need to multiply the top and bottom of the first fraction by 2. And on the second fraction, we need to multiply top and bottom by x. Because now we have the exact same denominators. Both fractions now have a denominator of 2 times x minus 2. Now on the top, we need to distribute the 2. We also need to distribute the x. The reason that's important here is because we want to add and subtract these things together. After all, this is a subtraction problem, not a multiplication problem. So we need to try to simplify this stuff together. Or think of it as using your order of operations. You have to multiply before you can add and subtract. So multiplying the first 2 through, we get 2x plus 4. Multiplying through the x, we get x squared plus 2x. And now when we go through and do this, remember that we are subtracting this entire numerator. Our denominator stays the same. We keep that common denominator, 2x times x minus 2. On top we have 2x plus 4. But now we are subtracting this entire binomial, so it's minus x squared and minus 2x. So we have to distribute that negative through. We're subtracting the x squared and we're subtracting the 2x. So we end up with this fraction now. So we still need to simplify the numerator to see if we can simplify. So putting it in order, looks like I have a negative x squared. If I combine my x's, I have 2x minus 2x, they cancel away, and I have plus 4 over 2x times x minus 2. Okay, well now we need to see if we can simplify the fraction. We've combined all our like terms, it's written as neat as we can get it. We need to see if we can reduce our fraction. So looking at the top, the first thing I see that kind of throws off bells and whistles is that my variable is negative. I don't want that. Anytime you see your variable being negative, you can most likely factor out a -1. And if I factor out a -1, I'm left with positive x squared minus 4. And that should be putting off bells and whistles in your head, because that is a difference of perfect squares. So that guy factors. So we now have -1 times x plus 2 times x minus 2, because that is how the difference of perfect squares factors. X squared minus 4 factors into x plus 2 times x minus 2. On the bottom we still have our common denominator of 2x times x minus 2. And now we can cancel. So our final answer, I'm going to throw that -1 out in front. If you want to leave it up on top, that's fine. But I'm going to say we have negative x plus 2 over 2x. And that would be our simplified answer. Let's try one of the problems with 3 fractions at the bottom of the page. So this is the first one with 3 fractions added together at the bottom of the page there. And in looking at this one, we see obviously 3 fractions, but let's see if we can factor any of our denominators. So our first denominator is x minus 4. Well, there's nothing we can do with that. Our second denominator is x. Nothing we can do with that. And our third denominator is 3x minus 1. Well, that can't be factored either. So they're all already factored. So to get our common denominator, we want each fraction to have that same denominator. So therefore, we want them to have all 3 pieces. So we're going to have x times x minus 4 times 3x minus 1. That is going to be our common denominator. So each of these fractions needs to have the denominator x times x minus 4 times 3x minus 1. Okay, so now looking at the first fraction, on the top we have our x plus 2, that was already there, but we only started with an x minus 4. So therefore we have added an x and a 3x minus 1. So that's what I need to multiply on the top. X and 3x minus 1. I need to multiply top and bottom by that. So I already multiplied the bottom, so here I'm multiplying the top. Looking at the next fraction, we started with just an x on the bottom, and we then multiplied by our 2 binomials, x minus 4 and 3x minus 1. So on top, we have the 2 that was already there, but we also then need to multiply by x minus 4 and 3x minus 1. So there we've multiplied top and bottom of that fraction by that to give our common denominator. And our last fraction, it already had a 5x, and on the denominator we already had the 3x minus 1. So therefore we multiplied the bottom by x times x minus 4, so on the top we also have to multiply by x times x minus 4. Okay, so we have now gotten our common denominators. In order to add across the top, we're going to need to go through and multiply each one of these together. So this does get to be a kind of a long process here, but we can handle it. So take it in steps. First thing I'm going to do is I'm going to multiply my x through that binomial. So on top, I have x plus 2 times 3x squared minus x. Looking at the second fraction, I'm going to go ahead and distribute my 2 through here. So I have 2x minus 8 times 3x minus 1. And on that last fraction, I'm going to go ahead and multiply 5x times x. which is 5x squared times x minus 4. All right, my denominators are still the same. So a little time lapse there. I got my same denominators. But now I need to go through and multiply the tops again, because I got to multiply my binomials before I can add or subtract. So on this first one, I've got a FOIL. So I've got to take x times 3x squared, which is 3x cubed. And I've got to take x times negative x squared, take 2 times 3x squared, positive 6x squared, and 2 times negative x, which is negative 2x, plus, foiling the next one, 2x times 3x is 6x squared, 2x times negative 1, negative 2x, negative 8 times 3x is going to be a negative 24x, and negative 8 times negative 1 is a positive 8. And our last one, we need to take this 5x squared and distribute it through our binomial. So that gives us 5x cubed minus 20x squared. So there's the numerators. Give me a moment and I will write all of our denominators, because those haven't changed. They're the same. Okay, so there we go. We have all of our denominators written in. And now we need to go ahead and make this one big fraction. So on the top, we are literally going to be adding all these guys together. So I'm just going to go ahead and write it all together. Now, please watch out for any subtraction, which thankfully we don't have any. But if you did, you would then have to take that negative and distribute it through each of the terms in just that one polynomial. Okay? We don't have any of that, so we don't have to worry about it. It's all addition. So we have 3x cubed minus x squared plus 6x squared minus 2x plus 6x squared minus 2x minus 24x plus 8 plus 5x cubed minus 20x squared, all over x times x minus 4 times 3x minus 1. All right, that looks nasty. So let's go through and see what we can do about reducing it. So our denominator has been staying the same this whole time. And let's start combining the top. So you want to start with the biggest power. And I see x cubes. So I'm going to take 3x cubed and 5x cubed, add them together, and give me 8x cubed. So then those guys are gone. Let's see here. What else have we got? We got x squareds. So we have negative x squared plus 6x squared plus 6x squared minus 20x squared. So 6 and 6 is 12x squared. And negative x squared and negative 20x squared is negative 21x squared. So essentially I've got 12 minus 21. Well, 12 minus 21 gives us negative 9x squared. Now all those cancel out. Next we have x's. So negative 2x, negative 2x, negative 24x. So that's negative 4x, and negative 24 gives us a negative 28x. Those go away. And we have plus 8. All right, so we look for any common factors along the top, and no. 2 goes into the 8s and the negative 28, but it doesn't go into 9. and 3 goes into 9, but it doesn't go into the 8s. So therefore, this is our simplified answer. Now, that was a lot of work. That was a large problem. They are not all going to be that big. They're not all going to be that big. So please don't think that your entire homework are going to be problems like this. But make sure you go step by step. The rules stay the same regardless of how large the problem is or how small the problem is. Good luck.